Hi everyone, welcome to today's webinar. My name is Charlene and I am part of the Axiometrix team supporting AP and GRASS products. And I am located at the AP headquarters near Portland, Oregon in the United States. I've been with the company for about a year and a half. Today's webinar isn't going to go into great detail about how to use APX 500, but if you're new to APX and would like a more general training, our global workshop series is still up and running. So if you would like to see where we're going and more info about that, you can visit our events page on our website. In today's webinar, we'll go through a brief overview of EN 50332, go through how to make these measurements in APX 500, look at some hardware options, and end with Q&A. And as Jen mentioned earlier, if you have any questions as we go through the webinar, you can submit them at any time using the question icon in the GoToWebinar interface. European norm, or EN 50332, is a standard covering personal music players, which we'll refer to as PMPs, and the headphones used with them. Some examples of PMPs include CD players and MP3 players, but PMPs have been mostly replaced by smartphones. The purpose of the standard is to help prevent PMP users from exposure to sound pressure levels that induce hearing loss over time. There are two parts of the 2013 standard that we'll be talking about in today's webinar. First, we have EN 50332-1, which we'll refer to as Part 1 going forward. This test is for PMPs and headphones sold together as a package set. And we have EN 50332-2, which we'll refer to as Part 2 going forward. These set of tests are for PMPs and headphones sold separately. We'll break these tests down more in the upcoming slides. There are two types of measurements we're working with in the standard: sound pressure level, otherwise known as SPL, and voltage. First, we have Part 1, player/headphone max SPL. Here's where we measure the maximum SPL of the PMP and headphones together as a package set. Next, we have Part 2, which has a total of 3 tests for PMPs and headphones not sold together as a package set. First, we have Audio Player VM. This measures the maximum output voltage of the PMP. Next, we have Headphone SPCV, which measures the simulated program signal characteristic voltage using both SPL and voltage measurements. And finally, we have Digital Headphone Max SPL, where we measure the maximum SPL of a digital headphone. Here we'll walk through the workflow of the SPL measurements in APX 500. We start with the APX octave analysis measurement, which acquires the signal in 1/3 octave bands, and you can see that result pictured here on the slide. Next, we apply our head-related transfer function, or HRTF curves, to convert the raw data to free field or diffuse field values. And next, we apply an A-weighting filter. This curve is what we're going to be working with to generate our final results. For our first result, we have an octave sum. This computes the power sum, or RMS summation, of the measured octave bands for the individual left and right channels. And for our second result, we have a power average, which gives us the average of the combined left and right channels. This SPL measurement is repeated 5 times and runs for a length of 30 seconds for each measurement. The headphones are repositioned on the hats between runs and accommodate for different fit variations. Next, we'll walk through the workflow in APX 500 for the voltage measurement. Here we have a noise recorder measurement that we're going to acquire the signal for 30 seconds. For our first result, we have a power average, which gives us the average for the individual left and right channels. And then we have another power average, which is going to be our second result, which will give us the average of the combined left and right channels together. Now we're going to switch to some demos so we can see these four measurements in action. During the demos, there may be some periods of silence while the measurements are running. We'll start with part one. This is an open loop test in which the program simulation noise test signal is played from the PMP into the headphones mounted on the hats. The program simulation noise test signal is a stimulus specified by the standard and has already been loaded onto my PMP. So here I have my project file that I'm going to be using for all four of our demo measurements here today. Here in this sequence list, I'm going to select the first sequence, which is part one, player/headphone max SPL. And here we can see that the player to headphones signal path is what we're going to be working with. So if we take a look at the signal path setup, we have our connector set to none, since this is going to be an open loop test where I am playing the test signal out of my PMP. We have two channels for our input. We have CCP power turned on. We have measure mode set to acoustic. And here's where we can update our microphone sensitivity. So you can update that to the appropriate values. We have our A-weighting filter enabled. And now what we're going to do is apply our HRTF curves by hitting this gear icon next to the EQ. And here we can see that we're going to uncheck the tracked first channel so we can upload two separate curves. So we're going to go ahead and upload our left ear, and we're going to upload our right ear. And if we click this gear icon to the right, we can see all of our curve values here. I've already inverted it ahead of time by clicking this button. So we're just going to confirm that both of those are set up correctly, and they are. And now we're going to go ahead and run the sequence by clicking the Run Sequence button. Here we have a prompt for our headphone test fixture. So I'm using our hats today. So I'm going to go ahead and put some info there. Next, we have a prompt for our PMP. And last but not least, we have our headphones under test. So now we have a prompt telling us to configure our PMP for playback to the headphones on the hats with the hats microphones connected to the mic inputs 1 and 2. So let's go ahead and connect those. So now we're going to position the headphones on the hats, which I've done. we're going to set the PMP player to maximum, and then we're going to start the program signal, and then we're going to click OK on this prompt, and this test is going to run for 30 seconds. So our first measurement has completed. We can see the data here in the back. And so we're going to reposition our headphones and repeat the program test signal by restarting it and then click OK. And we're going to do this for an additional 4 times for a total of 5 measurements. So now our measurement is complete. So I'm going to go ahead and stop the audio on the PMP. And here we have a report. And so you can see that at the top, these are from all the prompts that we had at the beginning. And instead of going through the results, displaying the report, I'm just going to go ahead and show you in the software. So we're going to go from left to right. So here we have our XY curves of both our left and right individual ears. So you can see here we have a total of 10 curves altogether. So for each of those 5 measurements, we have 2 curves, one for the left and one for the right. Here we have an average, so it's a combined average of the left and right per test. So here you can see we have a total of 5 traces, each trace correlating to measurements 1 through 5. And now down below, you can see now we have them, the results are numbered. So we have number 1 all, and we have number 1 average. So number 1 all is going to be the individual left and right channels. This is going to be the octave sum derived result. And if we go over to number 1 average, this is going to be the combined left and right average from the octave sum result. So this will give us our single value here in dB/SPL, which is going to be A weighted. And here we have our 2 individual left and right channels, which is also dB/SPL A weighted. And we can see that down here we have repetition number 2 or measurement number 2. We have number 3, number 4, and number 5. Next, we have part 2, audio player VM. This is an open loop test where the program simulation noise test signal is played from the PMP into 32 ohm resistive loads with the audio analyzer measuring the voltage drop across the loads. So for our next measurement, we're going to go over into the sequence control and we're going to select part 2, audio player VM. And so here we can see that a different signal path is selected. I'm going to go ahead and close the previous signal path we're working with and select player to load resistors. And here in the signal path, we can see that our output connector is set to none since this is an open loop test. We have 2 channels connected. We have turned CCP power off because we're just measuring voltage and we're not needing to use the microphones in the ears. And we have set our measure mode to voltage, and we also do not have any of our filters enabled. I'm going to go ahead and start the sequence. In here we have our PMP model information. And now we're going to configure our PMP for playback to 32 ohm resistive loads connected to the analyzer inputs. So this test is going to take 30 seconds. I'm going to go ahead and start playing the program signal with the volume turned to maximum. So our measurement is complete. I'm going to go ahead and stop the audio on my PMP. And here we have another generated report. I'm going to go ahead and go over the results in the software instead of the report. So we'll go from left to right again. We have our RMS versus time XY graph that you can see here. Next, we have our power average where we have the individual left and right channels. So this is the power average for the left. This is the power average for the right. And then we have a combined power averages of both of those values together to give you one singular value. Next, we have part 2, headphone SPCV. SPCV is the simulated program signal characteristic voltage. This is the voltage where the measured sound pressure level at the hat's ear is 94 dBA with the free field or diffuse field HRTF correction applied. This is a 2-part closed loop test where the APX generator feeds an amplifier which drives the headphones. The sound pressure level is measured first, followed by a measurement of the input voltage to the headphones. For the next sequence, we're going to go ahead and go up to the sequence control, and we're going to select part 2, headphone SPCV. So we're going to go ahead and collapse our previous signal path, and we can see that we have 3 signal paths selected to go over the next set of measurements. So we're going to go ahead and set all those signal paths up first. We're going to start with the output connector, and since this is a closed loop test with our 517, we're going to go ahead and use the headphone amplifier. We're going to have 2 microphones connected, so we have CCP power turned on. Using acoustic mode, if you need to update the sensitivity of your microphones, you can do that here. We have our A-weighted filter turned on, and we're going to go ahead and add our HRTF correction curves, just like we did earlier. And we see that it already stored that they have been inverted, so we're going to keep that as is and go ahead and close. The next signal path that we're going to use is going to be identical, so we're just going to confirm headphone amplifier, 2 microphones, CCP power turned on, acoustic mode, update your microphone sensitivity, A-weighted filter, and our HRTF. And in our last signal path, this is going to measure voltage, so it's going to be a little bit different. We still have our headphone amplifier as our output connector. We are still using 2 channels, but we have turned CCP power off, measuring voltage, and we have all of our filters turned off. So now that we have all our signal paths set up for all 3 of these configured, we're going to go ahead and start the sequence. So we can see here that we're still using our same test fixture, so we're going to keep that the same. And we're going to update with our headphones under test. I'm using a pair of Sony's this time. Here we can see we have our headphone SPCV test part 1. So here we're going to connect the output from our analyzer to the headphones that we're going to put on our hats, and then we're going to connect our hats microphones to inputs 1 and 2. So now we're going to place the headphones on the hats, and we're going to adjust the left and right sides of the headphones to match the sensitivity between the left and right channels to match as close as possible. That's pretty close. Let's see if we can get it a little closer. Okay, I would call that good. I think that's as close as we're going to get. So we're going to hit OK. Okay, so you can see that during that part of the measurement, we were regulating the generator level to reach 94 dBA. And just as a reminder, the SPCV is the voltage where the measured sound pressure level at the hat's ear is 94 dBA with the free field or diffuse field correction is applied. So that's why we're trying to match the sensitivity between the left and the right so we could target 94 dBA for both of those channels, for both the left and the right. So now that we've achieved that, we're going to go ahead and run the measurements like we were doing in part one. And so we're going to just leave the headphones where they were and proceed with those 5 repetitions that we had done earlier. All right, so that first part is complete. So now we're going to move on to part 2, which is going to measure the voltage. So we're going to go ahead and disconnect the cables we have currently with the hats connected to the analyzer, and we're going to go ahead and basically put a loopback cable on the analyzer so we can measure the voltage being driven to the headphones. Okay, and our measurement is complete. So let's take a look at our results. So we're going to go ahead and go back to the APX to analog headphones SPL-DBA signal path. We're going to go ahead and click on octave analysis. And here we're going to notice that all our results are going to look identical to part 1, where starting on the left, we have all 10 of our individual left and right curves. We have our combined averages of our left and rights for each of those measurements, and then we have our first repetition, octave sum, and power average results, followed by the second, third, fourth, and fifth repetition here. And if we jump over to the APX analog headphones volts RMS signal path and go ahead and click on noise recorder, we can see we have the same results as part 2 audio VM, where we have our RMS versus time XY graph, our power average of our individual left and right channels, and our combined average of our left and right channels. And last but not least, we have part 2, Digital Headphone Max SPL. This is a closed loop test in which the APX generator is used to drive the headphones at the required level of -10 dBFS. So for our last sequence, we're going to select part 2, Digital Headphone Max SPL. I'm going to go ahead and collapse these. And so in our demo today, we're going to be using I'm going to be using Bluetooth. So I have my output connector set to Bluetooth. I have my 2 mics connected or selected. I have CCP power turned on. Using acoustic mode, update your microphone sensitivity. You have our A-weighting filter enabled, and we're going to go ahead and add our HRTF corrections. And we're going to go ahead and run the sequence. So we can see that we still have our same HATS fixture info. We're going to be putting in our new headphone info. I'm going to go ahead and select my headphones. I've already previously connected them before. And now I'm going to connect our HATS microphones. I'm going to do the same thing where I've just repositioned the headphones, and this is going to repeat an additional 4 times. And our measurement is complete with the report. We can see that all results are the same. Looking at our XY graphs with our individual left and right, our combined left and right, and then our per repetition results with our octave sum and our power average for all 5 repetitions. And here we have a summary of the measurements that we've just run from our demo today. So we have our package set measurements, our non-package set measurements, open loop tests, closed loop tests, SPL measurements, each repeating 5 times for 30 seconds each, and voltage measurements, also running for 30 seconds each. And here are the specifics of the equipment I've been using for our demos today. We have a GRASS 45BC head and torso simulator, an APX 517 acoustic analyzer, and APX 500 software. And GRASS provides several KeyMar options to select from, as well as a 45CA headphone/hearing protector text fixture, which has occluded ear simulators and anatomical pinna that meet industry standards. And if you like information more about that, you can visit our website at grassacoustics.com. And as mentioned earlier, here we have the APX 517 acoustic analyzer. It has a built-in headphone amplifier and powered microphone inputs. We also have the APX 1701 transducer interface, which can be paired with any APX analyzer. This has built-in power amplifiers and powered microphone inputs. And alternatively, you can also use any of our other APX audio analyzers for these measurements with an amplifier of your choice. We have all the project files shown in today's demo available for download alongside TechNote 107. These project files were made with APX 500 version 9.1. And as shown in the demo, you can apply HRTF curves and A-weighting filters in the signal path setup. And to use the Octave Analysis plugin, you'll need to download it from our website at ap.com. The download is free and compatible with multiple versions of APX 500. And Jen will provide the links to both of those things in the chat if you want to go take a look at those. Now we'll transition over to questions. If you haven't submitted your question yet, you can go ahead and do that now by going to the question icon in the upper right-hand corner of the GoToWebinar interface. So we have some questions already. So someone has asked, how is the value of 10 millivolts per Pascal determined? So in APX, our default value is 10 millivolts per Pascal. So I was just using our default. The microphones I'm using were, I think, 9.5 or something like that. So it was close enough so I could just demonstrate how the measurements work. But for your own sensitivity, you would obviously check the data sheet for the microphones that you're using. Someone asked, what is the difference between EN 50332-1 and the IEC 60268-1 noise? So it's effectively using pretty much the same stimulus. We actually have more info about that in the tech note that kind of goes to it in a little more detail, but those two standards are connected to each other. Someone's asked, how do you determine the inverse of the HRTF? So when you have your headphone fixture and you have the pinna that comes with it, sometimes, so for at GRASS, we have like a spreadsheet that has all of our HRTF curves. And so you can actually download that from the GRASS Acoustics website. And then from there, you basically go to the column where your pinna is located and you can take those values and then you put those into APX 500. And in the tech note, we do have more explicit instructions on how you can kind of go to your the company where you got your headphone fixture from and then apply those values if you want more specific instructions. So someone has asked, is the EN50332 tool discontinued? So for those of you who may or may not be familiar, in the past, APA has developed a utility, which was called the EN50332 utility that worked alongside APX 500. And so all of those utilities were version and still are version specific. So for example, if you're running version 7, you would then need to use the EN50332 version 7.0 utility. And if you move to 7.1, you would then have to download a new utility and use that one. So effectively, we have everything, I think, up into version 9. We still have utilities. Starting in 9.1, which is the version that these project files are compatible with, there's no longer going to be a utility. You'll be able to download these project files for free, and then be able to basically run your own version, and you can then manipulate them as you want. And all of our project files are forwards compatible, not backwards. And if you do want to try version 9.1, I would talk to your sales representative for your region and then see if you can get like a demo license so you can check out how the files are working. Someone's asked, where can I find the source files that I've played? If you download the tech note, there's a zip file that has a whole bunch of other um, files in there. So they'll have the project files, it will have the source files that have the waves that I was using. It will have some example CSV files that you can use for HRTF curves, which I uploaded. So all of those things can be found together in the tech note. Someone asked if there are EN50332 sequences available for version 8. So no, not technically. You could, download version 9.1 and then kind of copy it over to version 8. Or kind of, from what I said earlier, you can use the utility and kind of work your way backwards that way. But we don't have any files that are specifically made for version 8. So someone asked, is the BS EN50332-1 noise shape available in the project file? So the source file that is loaded onto the PMP, that one is already inherently built into the file that is included with the tech note. In terms of APX, we do have that built into it natively. So when you go into APX and you select the noise, you can actually select the BSEN 50332-1 or the IEC 60286. I might be mixing up those last numbers, but that noise shape is built into the generator that you can select. So someone has other analyzers that aren't a 517 and want to know if they can still run these tests. And yes, you can. There are going to be some things that are visually different in terms of the output connectors that you can select and the input connectors. In the tech note, I actually have some instructions on specific analyzers and how to do that. But essentially what you would do is if you have like a 555 or a 585 and you have your unbalanced analog connectors, you could use something like the 12 or GRASS power modules, like the 12BE and like that whole series, and connect your CCP microphones through those power modules to your analyzer, and then connect your preferred amplifier and be able to run all of these sequences. Someone wants to know where to download the project files, and those are with the TechNote 107, which Jen has dropped the link to in the chat. Cool. I think that's all we have time for. There's some other questions that I can follow up via email. Otherwise, if you have any more additional technical questions, you can email us at the email addresses on the slide, techsupport@ap.com or support@grassacoustics.com. And thank you all for attending today's webinar.